Bismillahirrahmanirrahim. Assalamu alaikum. The students will come back in lecture 6 student. This is lecture number 6, okay? And we start example number 1. So basically you see in lecture number 5 that how we apply the method of DDM, okay, to a frame structure, and the whole procedure, okay, the same usual way. We need to calculate loads, then we need to select our interior frame and exterior frame, then we need to find out our half column strip. If we for interior frame we need half column strip, then we need middle strip width, and then the static movement, okay. And after getting static movement, you have to use coefficients, longitudinal coefficients, and then you have to use transverse coefficients, okay. So you see all these calculations and how we apply. And then remember, this point is very important, and I will explain again here that once you got your movement like 168, 283, this movement is representing as kip feet per strip. For C is this strip, okay. Now this is the total movement which is basically over this strip. Now if you want to convert it into longitudinal direction per strip width, or you can say per foot width, or you can say kip foot per foot. So what you need, you have to divide this 168 by the width of this column strip, and similarly this 112 divided by 2, okay, which is around about 56. So if you want to convert them into per strip width or per foot, okay, so you need to divide them by the half middle strip width, that is M is by 2, which is 5 feet, and similarly C is, that is 10 feet. So here you see, and if you do that, you see the movements. Now remember, these are the movements which is in longitudinal direction. How we represent these movements? Remember, the representation of these movements will be look like in this shape. Remember, there the movement is 0, okay. At the edge the movement is 0. Now the movement is positive, then the movement is negative, then again the movement is positive, then again the movement is negative, okay, and so on. The process will be continued, and at the final edge basically the movement again 0, going negative, and then positive. So this 9.4 is basically this side, and this 8.8 is basically that side, remember. But this is for this middle strip, not for the column strip. So for the column strip, you see here the movement will be 28.3, okay, and here this one, and then the column of the face, although there is 0, but here you see there will be 14 kip feet movement. So this is the variation, okay. If you look this diagram in 3D shape, so it basically decreasing, okay. The movement is basically decreasing. And if I show you, for example, let me show you here, okay. Here, let's say here, this is the interior frame. So at the face of the column, the movement is, and then it become positive, then the movement become negative, okay. So here basically the movement is 140. Remember, the movement is 140, and here the movement is to 140 and 28, okay. Here it will be 28, okay. Now at the edge, or at the corner of the half middle strip, the movement is 0, then it going positive, then again it is negative. So this is a kind of representation. Here the movement is positive. If I draw a line, let's say this is the line, okay. This is the line in 3D basically. If I draw a line, okay, like in this shape, so look to the variation of the, okay. So this is negative, here 0, there positive, and positive amount, that is 11.2. So here is 11.2, and here the moment is again negative. Remember, this is negative moment, but this is smaller. Okay, this is smaller. This is 9.4. So this is 9.4. Okay, and again to this side. Again, if we come toward this side, so here again, there the picture will be clear. Okay, the moment is 0, then it positive, then it goes up, and this one will be the value. So here you see this kind of shape. In 3D you see this kind of shape. So you now understand the moment diagram, how it looks like. This one again is 9.4, and this is the positive movement, which is 11.2. Okay, here the positive movement is maximum, and you see here this is 16.8. This is 16.8. Remember, the positive movement will be 16.8. Okay, and there is 0. Okay, now here you see the movement is 0 in longitudinal direction or EW direction, but once we analyze the frame in north-south direction, then you got movement here. Okay, so this is, remember, and maximum movement will be here. Okay, so this is the procedure how we can draw these diagrams. Similarly, this kind of continuation will be start again. Okay, this will be the way. Okay, and similarly here. So the moment diagram will be looks like again in this shape. Okay, there will be negative, there will be negative, there will be negative, and if you draw a line here, for example, a reference line, so there will be positive movement, there will be positive movement, and there will be positive. So this kind of, you can say, wavy surface you got. Okay, kind of wavy surface you got along the interior frame, and similarly along the edge frame. Okay, here you also got such kind of variation. There the movement is negative, sorry, it will be zero, it will be positive, then it will be negative. Then again you see the movement is negative, then positive, then again negative. And here you see the movement is 0, then going positive, then again it is at this line, at the column face line, basically you see the movement is again negative, and then again positive, and at the column line basically the movement going to be negative again, and you just join these lines, you got your movement diagram look, which will look like in this shape. Now to cover these movements, you have to provide longitudinal reinforcement in this direction. For this positive reinforcement, you have to place bars in this direction, and similarly for this negative movement, you have to place bars in upper portion of the slab. So this is the way that how you can understand the mechanism. Okay, here you need negative reinforcement, here you need positive reinforcement. Okay, I think you got the picture right now, the area of steel, how you can distribute area of steel. Remember, you have to provide steel in this direction, in upper portion or in upper side of the slab, and similarly in down surface of the slab. Okay, which will covering this movement. And the one important thing you must understand that the value of an exterior frame, once we analyze, okay, here you see 74 negative, but here again positive movement is also, but here it looks smaller. And similarly, if we target this positive movement 59, and we come here in here 16.8, so this is very important. This is very, very important that in the middle strip the positive movements is minimum, while in the negative movements at the faces of the column is very high. Okay, so this demands higher reinforcement in the negative zone. Okay, negative tension zone. So you must look to this variation, remember. And in negative regions, it demands higher amount of steel. So this shape, once we basically analyze this frame in transverse direction, then that movements will give us the amount of steel in transverse direction. Then the movements which we got from the transverse analysis of this frame, then that analysis will give us the positive and negative reinforcement in transverse direction. Okay, So let's start that analysis. Okay, in transverse direction, okay, remember in transverse direction the procedure is same, the method is same, the only thing which will be differing is the direction of your frames. Okay, is the direction of your frame. Let's say we analyze the frame in east-west direction. Okay, east-west direction, you see, but now we start the analysis in north-south direction. Clear? North-south direction. So what we have to choose, basically we have to choose this interior frame. Okay, we did the analysis for this interior frame, and then we need to select the exterior frame, and the exterior frame will be, let's say, this one. Okay, let's say the exterior frame will be this one, the edge it will be. Okay, so this one. Okay, remember, you don't need to be confused. Okay, so this one will be exterior frame and this will be interior frame. Again the procedure is same, we have to divide them into column strip and half metal strip, half metal strip, and similarly here we have only one column strip and one metal strip. The only thing which will be changed is the direction of your L1 and L2. Here the L1 will be this direction, this length, remember, that is 20 feet. L1 will be 20 feet and L2 will now, as that is the transverse. Okay, so in this case, remember, L2 is basically half of this panel and half of this panel. So 25 divided by 2, 25 divided by 2. So L2 will be now, it will be changed, it will be 25. So now only thing that is L2, L1 will be changed, while the rest of the procedure is same. Okay. So this is the now the step number 3, frame analysis is in its direction. Okay, so you see the interior frame is selected, L1 is now changed, and you clearly see L1 is your 20 feet. Okay, that is center to center distance, because our direction of analysis now in north-south direction. So that's why L1 will be now rotated. And the east-west direction, L1 is this direction, because our analysis direction is this in this way. Here the direction is analysis direction in this way. So that's why L1 will be now this one, and L2 will be now transversely to the L1. Okay. So only thing changed, that is the dimensions of L1 and L2. Okay. The rest of the calculation, you see column strip, middle half strip, middle half strip, column strip half, you will determine the length. L1 by 4 here, remember here L1 is governed, in east-west direction L2 is governed. Again you have to find out your MS half, and MS half is nothing, it is just only this 25 minus column strip width. Okay, and then divide by 2, so you got that value. Okay, now it increasing, and again you need your M naught the same way, but here remember Ln will be change, will be 18 point something. Okay, I think so, because 20 minus 14 divided by 12, and L2 will be 25, so the movement will be larger, because now L2 is larger. Okay, sorry, L2 is larger, yes. And let me, yes, W is that is constant. Okay, so again M negative, M positive, these are the longitudinal distribution in this direction. The movement at in the, you see, this is M negative, M positive, M negative, and again in the exterior panel what we have, M exterior negative, M exterior positive, M interior negative. So this M exterior positive is how much? 0.26. Okay, you all know this, 0.26 M naught. This M exterior positive is how much? You all know that is 0.52 M naught. Okay, and M interior negative, you know this is 0.70 of M naught, and M negative is 0.65. Okay, 65 M naught, and M positive is 0.35 M naught. Okay, so this will give you the longitudinal distribution of moments. Then you have to transversely distribute these moments. Okay, So to transversely distribute these moments, what you need to transversely distribute these moments, you have to multiply. This moment will be remain 100% at the face of the column, clear, 100% at the face of the column, while 0% will go towards the middle step. This is remember. While this moment will be distributed, okay, it's the whole moment which you got from this figure, it's I think so it is at 60%, okay, at 60% mean that 0.60 will be in column strip, while the rest 20% will go here, okay, and 20% will go here. Similarly, 70% will be distributed into 75 and 25%. 25 means 12.5% will be here and 12.5 will be here. Similarly, 65% will be distributed into 75 and 25, and 35 will be 60 and 20%, you can say 40%, 20 will be here and 20 will be here. The whole procedure I explained, no need of any further explanation. You see all the coefficients, okay, and once you see you got your movements, you got your movement, you have to just represent them, okay. You just need to write down at their specific points. Now you need to distribute them. So clearly you see the whole movement will be absorbed here, and 0% will go transfer toward the middle step. Now here you see it's 60% movement will be absorbed here, while the rest of 20% will be here and rest of 20% will be here. Similarly here 75 will be left here, while the 12.5% will be here and 12.5 will be here. Similarly for this, and similarly 60% will be here, while the rest of 20% will be here and 20% will be here. You see the calculation, and further you have to divide this. As you see, these movements are basically, for example, the movement which I got here, let's say this is, if you, here I use the shortcut, remember, you have to take 60% and then, okay, that movement should be divided by the column strip width, okay, by the column strip width, and similarly by the movement which you got here, basically you have to divide them by the middle strip. Right, okay, you see the whole calculation, how 11 comes into picture. You see 110 divided by 10, 110 is already here, and that is divided by the column strip width. So this means that now the movement is converted into longitudinal direction per foot width, okay, the same way as I explained in longitudinal direction, okay. And from where this 13.2 comes, remember 13.1 is explained here. 219, I already mentioned, 219 times 60%. So you see 60% and divide by the column strip width. Now I just shrank the things. I just skip all the steps, and in one step I did all the calculation. Okay, 13.1. Similarly 5.8, you can see that 20%, because 60% will remain here, while the rest of 40%, half will be here, half will be here, and half will be here. So that's why here I am taking, and for the rest of the nothing will be different. Similarly for exterior frame, this is your exterior frame, and you need to divide them into column strip and middle strip. Now here remember L2 is this distance, okay. So how you can determine this distance? It is, you know, it is very clear from the picture. The distance between these two column center lines is 25 feet. So first of all you need to divide them. So 25 divided by 2. 25 divided by 2. Now L2 will be how much? L2 will be 25 divided by 2 plus you have to add up that half column side, okay, that half column side, and that is h divided by 12 divided by 2. Okay, so you got your L2 and L1 value will be clear, that is 20 feet. Okay, now the rest of the calculation is same. It's you M exterior negative, M exterior positive, M interior negative, all you just symbolically write them, column strip, middle strip, okay, and you got your L2 value like I explained it. Okay, L2 will be this one, L1 will be 20, it is clear. Now the width of the column strip is the 20, that is the panel width divided by 4. Okay, so 5 plus h divided by 2. Okay, and the rest of the calculation is same. Okay, you just to find m naught, and once you got your m naught, you have to find out these movements. You need to represent these movements, write down these movements on the frame, and then by using the coefficients, by the transverse coefficients you got here, I again shrink the things. Okay, you see 50, this is 58, actual value is 58. Now divide this by the column strip width, that is 5.58, you got 10.4. so the same way, okay, this is the way. Okay, this is M exterior positive, remember M exterior positive. So this okay, this is not complicated, it is easy. Okay, you can do this. Okay, and then this is the last step, you can say the final representation of all movements as we did in east-west direction. Okay, all the movements now I already explained in lecture number 3. At the final stage you have to combine your exterior frame. This is your exterior frame and this is now your interior frame. So you have to combine them, join them. Now you see, this is the meeting line of the exterior and interior frame. So here you see 0, 0. Here you see 11.87. We ignore the movement of interior frame because that is smaller than this one. So we have to select larger values. And here you see 10, while here 9.4. So they are close. Okay. And okay, this is 28.3. All these movements are there. So you just need to combine them. Okay. And here from here you can choose basically the larger values. Okay, you can choose the larger values. So again after this we will start the design for east-west direction, and similarly you have to represent your north-south direction movements. Okay,